Vehicle to Grid (V2G) technology. Powering a smarter energy future. Introduction to V2G. Vehicle to Grid (V2G) technology is a breakthrough innovation in the electric mobility and energy sector. It enables electric vehicles (EVs) to not only charge from the power grid but also to return stored electricity back to the grid when needed. The concept of bidirectional energy flow. Unlike conventional unidirectional charging, where electricity flows only from the grid to the vehicle, V2G introduces bidirectional flow. EVs become dynamic energy units that charge and discharge based on the grid's requirements, turning EVs into mobile energy storage. When idle and connected to a compatible charger, EVs act as distributed storage systems. These mobile batteries can support the grid by supplying stored energy during peak demand or power shortages. How V2G works. V2G systems utilize bidirectional chargers, smart meters, and communication protocols. These tools allow grid operators to signal EVs when to absorb power and when to return it, depending on real-time grid conditions. Smart grid communication. Smart software platforms manage this energy exchange. Through programs like virtual power plants, VPPs, EVs are coordinated as a fleet to offer grid services without compromising user convenience. Peak load management. During high electricity demand, V2G-enabled EVs can discharge power into the grid, easing pressure and preventing outages. This function is critical for balancing supply and demand, especially in urban centers. Supporting renewable energy. V2G plays a pivotal role in integrating renewable sources like solar and wind. EVs can store surplus energy during high generation periods and release it when production dips, smoothing out variability. Financial benefits for EV owners. EV owners benefit by charging at low cost, off-peak times and selling energy back during peak hours. Some programs offer financial incentives, potentially turning EVs into revenue-generating assets. Environmental impact. V2G helps lower carbon emissions by reducing reliance on fossil fuel plants. When powered by clean energy, EVs discharge green electricity back into the grid, enhancing sustainability. Emergency power and resilience. In emergencies or blackouts, V2G-capable EVs can provide backup power to homes and buildings. This vehicle-to-home V2H feature adds resilience during natural disasters or power cuts. Infrastructure requirements. To implement V2G, certain elements are essential: compatible EVs, bidirectional chargers, grid agreements, and smart communication systems. While the technology exists, adoption depends on supportive infrastructure. Battery life and degradation concerns. One challenge is battery degradation due to repeated charge-discharge cycles. However, some studies suggest smart management can minimize this effect or even enhance battery performance. Standardization and policy support. For V2G to scale, global standards and regulations must align. Protocols for communication, charging, and safety need to be uniform across manufacturers and grid operators. Current pilots and innovations. India is exploring V2G through projects like the Kerala State Electricity Board, KSEB, IIT Bombay collaboration. Globally, automakers like Nissan are preparing to launch affordable V2G-ready EVs, signaling growing momentum. Future of V2G technology. V2G is poised to reshape both transportation and energy sectors. As EV adoption grows, V2G will be a cornerstone of smart grids, enabling a cleaner, more efficient, and resilient energy future.